Alrighty. Just gathering some references. Gonna be making an enemy, and I'm thinking kind of like something weird. You know what I mean? Like this is gonna be a Souls-like game, so that kind of gives me Wolf vibes in some ways, kind of like Elden Ring. But I also want something that is going to be relatively weaker, like a slug or a bug of some kind. Um, and so let's just kind of think here for a minute. Gather some more references. How about let's look up like a beetle. Oh yeah, my dad's got a lot of those at his house, especially during the summertime. Okay, okay. Got some decent looking creatures there. And of course, this is like a two-dimensional game. We're gonna want I'm gonna start making like a outline in no particular color. I'm gonna turn on some mirror here. Like that. Come down. Be kind of like a beetle looking thing. Just gonna kind of go like this. And then kind of like that. I'm going to turn symmetry off here. Thinking that should be fine for like a shape. Now the shape language might be a little messy, I suppose, but you know, at the end of the day, I think it will be fine. Oh. Oh, that's looking like an octopus now. See the eyes? Hold on. We got like an octopus. I might just run with that, guys. To be honest, that's hilarious. Well, maybe something simple like that, right? I mean, we don't have to go crazy and just have him kind of like do like a squash and squish. And what we'll do here, so I am no artist, but I do know that having a color palette helps tremendously. And in fact, having a color palette that kind of coincides with what you already have is best practice. I want to see. Oh, I probably made that on my other device. Let's just go ahead here. I'm going to grab that color. I'm going to copy this. And that way we can go into the Adobe Color guy. I'm going to try a split complementary. Oop, we copied that one. We want to copy this one and paste it over here. So change color, bam. Right. So that gives us kind of a nice little thing here. I think this color here is going to be the eyes. So we're going to come over, go here, paste that in, go like that. Maybe not the mouth too, but we'll get to that point. I'm going to copy this, paste it. This is going to be the outline here. So just kind of make it an enemy. Going to do a couple animations. Nothing serious. And copy that. Oop. Paste that there. Boom. And then we'll go ahead, copy that color. You know what, that might be nice for the outline actually. Something like that. And then we'll use that color kind of as some shading here. So I'm just going to kind of store those colors like that. Go ahead, do some outlines like that. And then we'll grab that darker color, shove it in like that. Oop, that's going to... I'll put that color there. Brown. That color there. This color kind of as a highlight. So I think that's fine. Again, this is just really my game doesn't need enemies, but I'm not going to go crazy in depth since I'm not really an artist at all. But I am learning to be a little bit more particular in this type of stuff. So what I'm going to do here, I'm going to delete his head like this. And I'm actually going to make a new layer. I'm going to paste that there. And then on this layer, I'm actually going to take away half of his legs there, his left legs, and make a new layer. Paste his legs back. So now we have a head layer, a left leg, and a right leg. I'm actually going to name these. So we have a right leg, we have a left leg, and we have a head. I'm going to file, save as, and I'm going to call this my enemy. Honestly, my enemy checkpoint. Ooh, well, good thing I saved. That was funny. So here's our enemy here, but I need some animation. So I'm going to right click here. I'm going to say a new frame. And I'm simply going to grab his head like this. I'm going to make sure I'm on the head layer. And I'm going to move it down. So we kind of have this motion. And then I'm going to do a new frame. And I'm going to grab his left leg. And I'm going to do, I'm kind of thinking like that. And then do a new frame. And we're going to grab his left leg and put it back. Grab his right leg and do that. Oh, looks like I kind of like that. Gonna be a hot second. So let me just do this. Oh, sorry about that, guys. You know what are you gonna do? I got called by my girlfriend. She was like, "Yo, what you do?" So yeah, so it's kind of like I guess we could use that as his walk animation. It is kind of funky looking. So yeah, so that could be the walk, and then I will do an idle animation, and I'm kind of thinking, oh, what yeah, so I'm kind of thinking more like that for an idle. And in fact, if let's just say for example that this is my idle, which is, you know, a little fast. In my game engine, I'm able to separate these frames, and I think this would be a fantastic way to kind of showcase that. So let's say, boom, I'm done with the art. I'm going to export a sprite sheet and open sprite sheet and hit export. And so here's my little frames here. And I'm going to go ahead, file, export as. I'm going to choose a file location. And here, I'm going to go ahead and we're going to go into the actual GitHub directory. Documents. Actually, no, we're not going to go to the GitHub directory. I'm going to go into pictures here. And I'm just going to call this squid enemy. Like that. Export, boom. And I'm going to close and don't save. So here's kind of like the main thing here. What I need to do first, I'm going to hit simulate. This is what I currently have. The character can roll. There's a light source. There are collisions. There's a health bar with a test to be able to see it. And then there's some attack animations. Some very simple so far. I'm going to go ahead and clean that build. And yesterday, I kind of showcased how I've split this into a manager area with a library, And then I didn't really talk too much about the asset preloading here. And so I think today, showcasing how I'm going to go about this and the other, that little art portion I just did is going to make a little bit more sense here. So what's actually happening is I have an enumerator here, image data, and it's, just kind of keeps things organized for me. And in this function, pass loaded texture, we take in a number, otherwise known as, the enumerator, the value, and that value is being checked and it says, hey, if that value is 0 or 1 or 2 or 3, notice if I hover over, you can see what those values are equal to. And in case you didn't know, in C++, I could say that equals 5, and everything after it gets incremented up as well. If you don't tell it, it will be 0. For explicit sense, you can tell it to be 0 for readability. But anyway, that should be absolutely fine, just kind of leaving it there like so. But when you put in a parameter number into this pass loaded texture, it's going to create and update this texture. So instead of like loading from memory or loading from a file, it's actually creating this these images, and these images are these CPP files. And I'm going to kind of show how I go about doing that. So I'm going to open up GIMP here, and I'm going to go File, Open, I'm going to go into Pictures, and we're going to click on our squid enemy and hit Open. And so this here is our sprite sheet. If I go to File and then Export As, and instead of exporting it as a PNG, I export it as a C file. And I'm just going to leave all this and hit Export. Then I'm going to go ahead and close. So what that did is it exported a squid enemy C file right here. I'm going to go ahead and copy that, and I'm going to go into my GitHub directory. So GitHub, open template, asset preloader, and we're going to go ahead and paste this C file. And we can see that C file right there. All right, so notice it has a bunch of GU ints and then all this crap here. What I'm going to do is I'm going to hit File, New File, and I'm going to call this Squid Enemy Header. I'm going to save it. And I'm also going to do File, New File, Squid Enemy.cpp. And save it like that. So here in my other headers, I have basically the orientation in which I need my data to be in. So I'm going to copy this and go over here and paste. The only thing I need to change is the amount of pixel data and the name of this struct. This is a C style struct here. And so we're going to call this squid enemy image data. So I'm going to backspace and go squid enemy image data. I'm going to copy that, put that there, and then I'm going to call this squid underscore enemy. And this is just the naming convention that I've chosen here. Under the original C file, right here, we have its pixel data. I'll go ahead and copy that. Go back into our header here, and I'm going to paste it. Now I'm going to hit File, Save, and we're going to go into our C file, and I'm going to Control-A, Control-C, and go into CPP and paste it. I'm going to scroll to the top, and I'm going to delete all of this. I'm going to delete that comment, and I'm going to tell it hash include squid enemy.header. And we're going to call the name squid enemy image data, or the type, and then the name squid enemy. So I'm going to go here and type squid enemy image data, squid enemy. This is what it equals. I'm going to save it. And before I forget, two things are going to happen. I'm going to delete the original C file, and I'm going to come up to the make file here, and I'm going to add squidenemy.cpp to our compile list. I'm going to save, and I'm going to go up to assetlib.header. So in the libcpp, it allocates this memory loader, and in the header, we kind of define what's happening here. And in the enumerator, I'm going to go ahead and add squid enemy. And I'm going to add another comma just to be helpful to me next time I add something here. And I'm going to say if data is squid enemy, and notice how it starts auto-populating. This is exactly what I need, because we need the width, height, and pixel data from that type there. I'm going to hit File, Save All. I'm actually going to close out of that. And I'm going to close out of my terminal. I'm going to make sure I'm in the GitHub Open Template Asset Preloader. And I'm going to type make clean, clear, and then I'm going to type make. And here, just checking. So there's one thing I have forgotten to do. We're going to open this up, and notice even though this is here and these are here, I never included it. So hash include squid enemy, save, go back. We're going to clean that build and go ahead and make it, and just check in here. Oh, this error is something that I have happened a few times, because everything's const. And if we look here, that's an extern const, right? So since this is const here, this right here needs to also be const. Very easy to forget that. Really no big deal. You know, the errors kind of help you find it. And then of course when I hit make, boom, it has made it. And if we look here, we do have our lib asset. So now I'm going to go ahead and close out here and here. I'm going to close out of the other terminal, and I'm going to close out of those two windows and go into my Souls-like folder. And we're going to open up our code editor. So we've done a couple things. We've made the asset, and then I turn that asset into code, and now we loaded that code into our library. And now we have to access it. So over here in assets, this is kind of where we are adding these assets at. And the way to get here, get these enumerators, this is actually coming from the interface file. Interface doesn't live here, it lives in manager. So I'm going to go into our manager here. I'm going to go to interface. Here is our list here, and I'm going to add squid enemy like that. I'm going to hit file, save, so we have that here. I'm going to make clean and clear, and then make it again, and close out of that. And so now, when we add to this assets, I should be able to say add, then asset, squid enemy. And so what this preload does is it grabs the type that we place in it, and it creates a pointer, it grabs that information from our library, says, hey, library, I want you to hand me that texture that you created when you were compiled. And then I'm going to add that texture to a list. This way I can access that list when I need to. And so far we have that information there. Now, this squid here, he's going to be our enemy. And I'm going to go and just do a new file. And I'm going to call this enemy.header. And here I'm going to make a struct called enemy. And all entities in this type of program I'm making, not only enemies, but anything that can be interacted with, so on and so forth, like the player or the light pillar, these things need to inherit from base. Now base here, it has a lot of the boilerplate, a lot of the collision code. It has the mailing system. That way it has a channel, so on and so forth. And the other thing too, each one of these enemies are going to need a health bar, right? Because this is a Souls-like game. We do need each enemy to have its own health system. So over here, I'm going to grab from base, which means I'm going to have to include, it looks like I had a caps lock on, so hash include basic there. And the other thing, if we notice here, so let's go to player. Player has controller and watchable here. And I'm almost wondering, right, because this UI here, it does work for the player, but it also technically should work for really anything. And so having UI defined in the player script, in the player script is probably not best. I probably want to move that over to basic. And so I think I'm going to do that real quick. We'll just grab that. I'll come over to basic here, and I'm going to put this about there. Should be fine. And then here, we're going to go ahead and grab this information. That way we only have player in the player code. And I'm going to go back up to the basic.cpp, and we're going to kind of shove it after controller, but before base. So right about there. And so this is just so I can access this information as well for the enemies. And just to see here, if I hit make, we should be able to compile this, and then we have no changes, so everything is as it should be. And now let's go back into enemy header. We want to define our enemy here. Just kind of taking a look at player here. We have a health, we have a stamina, and so I think we're gonna basically do very similar there. And other than that, I think maybe get values we might do as well, because the basic header or basic CPP. Let's try to find the get guy there. Yeah, so that does need to be redefined. An enemy. So we're going to come over here. Enemy needs some type of health. Stamina might not be the word for it in this case, right? Like this might be more like magic value. It's attack type doohickey. And then we need to have a override on get values here. So I'm going to copy that as well. Then we need some type of constructor here, and we are going to take in that asset reference. That way we can basically load in that texture there. And I'm going to make a enemy.cpp, enter. We're going to hash include our enemy header, and from our enemy class, notice it is starting to auto-populate a lot of this stuff, which isn't the worst thing in the world, but it's definitely, kind of funky sometimes when it does that. Interestingly enough, it did that correctly there. And this is kind of like one thing I will show here in a moment as well, because player does have the animations here. I want to say, do I have an anim.play at any point here? So we have a set camera, set position. This animation just playing all on its own. Just kind of check in. We have an update. That's what I'm looking for. This is... So this is where things are going to get a little different, because update exists because the player has a controller, and the controller here. So if I go, it's in the manager library, but the controller has update. Nothing else actually has the update. So, we're gonna sneakily get this guy to animate in a different way here. And so for now, I'm just gonna make kind of a void update here, and then very similar to yesterday, the plan is we're going to do it wrong, and then we're going to do it correctly. And so having this update like this allows kind of a quick test to see if this animation is going to play. And then the other thing we need is to define get values here real quick. I'm going to grab it like this, go here, and do enemy get values. And for now, we're going to return values like so. File, save. And now we want to add this enemy into our actual game here. So in loop, we're going to hash include our enemy. I'm going to make a pointer. So enemy, pointer enemy. Inside the loop script itself, in the initialization function, I'm going to come right after player and do enemy is a new enemy, loads in the asset. I'm going to set its position. And then I need to add it to the scene here. And so we're going to do or add to scene guy. So enemy add to scene. I'm going to do the entity layer. We're going to do the enemy itself. So this should make the entity viewable. So let's just take a look real quick. Do make error. View was not declared in the scope. So let's take a look. We'll take a look at player first. So inherit space, controller, watchable. I'm going to make clean just to make this a little bit easier to look at. And so here, let's take a look at base here. That does have the viewables. I do wonder why it's not not color coded at the moment, so that's interesting. CView does exist. And what happens here? Set texture. It's just saying that the enemy kind of looking here, because we should have the same difference. Let's take a look at the light pillar. Should be fine. And what was the error? In member function void enemy update enemy.cpp view was not declared in this scope. So that is interesting there, because view should be part of base. Oh, hang on. Right, for auto view in viewables? That is definitely a thing. Can we reach viewables from here? Should be able to. Viewables. Go ahead and make clean here, clear. And if you're just joining, I've been showing how I go about adding assets into the has no set position. How I go about adding enemies into my or not enemies, but assets in general into my game engine here, and running into a couple funny scenarios. We'll just kind of borrow your set position player just real quick here. Boom. Go back into enemy here. And then for here, we are going to do the for auto view in viewables. Then we're going to animate. So that's there. And currently, if this compiles, the enemy will not. Viewables was not declared in the scope. Oh. Okay, so we got it to compile here. The enemy will not update because I never called it to do this. And right now we're just checking, can we see it? Is it in the viewport? And there it is. So there he is, and if I walk into him, we will walk right through him. There's a couple reasons why. So over here in the loop, even though I've added our enemy to the entity layer, I never added him to the collision manager or them. So if we go here, and now I add enemy as so, this will collide. So if we walk down, now we have collision. Now notice this is kind of an interesting thing. When I bump into here, do you notice how that enemy is moving? Easier to see if I go like this, or even better, like this. This is because I've kept up to this point an optical illusion where it looks like the UI is moving with the player, and this here would be like a collision. And we basically need to tell the game, and I wonder what's going to happen. Yeah, like that. That's interesting. So, well, we basically have to tell the game to maintain that illusion there. But for now, we're going to clear that out. And to quickly see if that animation plays, I'm going to do enemy update. And this is the incorrect way in my framework to go and do this. And notice we do have an animation. And the idea here is because enemy has a texture like this, we're going to have multiple. One is going to be a 0 through 2 here, and then the other will be a 0 through 4. And so this would be the idle animation, and then the 0 through 4 would be the actual walk animation. But we also kind of want to maintain that that collision thing. And I might end up having to go through my collision system here, because maintaining everything not to move may become an issue. And so I'm just going to try something real quick. I think I'm just going to walk right through these objects now. Yep. And so we really want to have a system where you collide, you stop moving in that direction, and then the the resolution doesn't move everything. And so I'm just going to kind of take a look here, and we're going to go into the light pillar, and I see this maintains a set position. And I think I might just end up doing the same thing with the enemy for now. Well, we do have a set position like that too. Am I calling this set position anywhere? Oh, I am. In the beginning of loop here, I am calling that set position. But I think I want to call it more like this. So, like I said, we're going to do things wrong, and then we're going to correct them. So the point of this so far was, hey, we made the enemy, we loaded in through our asset manager, we added it into our game, we got it to appear, we got it to look like it's animating, and now we're going to break this and do it differently. So here, I'm going to do an SF vector 2F position, and we're going to replace that here as well. Position override. And this will override the set position Actually, no, that's a get position there. Ba, 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 because you're a status guy. I don't know. I don't know if that's actually overriding anything. Because that's the base class. Now I only see a get position there. Yeah, so here's kind of the thing here. When I was thinking about this as like the lighting pillar to get it to not move, the lighting pillar has a applier light guy as the listener in a sense, right? So the light pillar is the radio tower, and then the light itself is a listener, and it has a set position. And so what happens is inside of our actual light guy, we're setting the position, which is grabbing that index and then moving it. And so over in, and let's go into loop here for a second. When we added it to the, let me find, yeah, right here, the signal manager, when we add it to subscribed, it goes there, and it kind of stays, right? Because the light itself is the light pillar, but the lights is a list that contain the actual C light itself. And when we bump into lights, this sends a message, hey, here is my current position, and this thing here goes, I will stay at that position. Similarly, kind of want like a very similar thing here, except the only difference is this guy is a since he's a base, he's a status. He's not an applier. And there's kind of two ways I'm thinking about doing this. If we make enemy also a listener and an applier, so a little bit of both, we might be able to remedy this a little quicker. So I'm going to inherit from I apply here. And this will have a override here. But there's a couple other things we need to override, and we're going to go into basic here, into the UI, because it has a couple things here, like a set values and a set position. So I'm going to Control C. We're going to go back into enemy here. Function definition, set channel. You know, and that's the thing, since we have two channels, technically, with the same guy, and one of them is already defined in base, I'm not going to redefine that. And instead, we're just going to do a set values here. And I believe that just takes in a set of values here, kind of like so. And we're just going to leave it. We're going to leave it empty for now. This is just a stub. Technically, we don't have to fill it out. It just needs to exist. In fact, you know, we could return like that if we ever so chose. But the main thing here is now set position is actually a thing. And this set channel right now is coming from our base guy. And I wonder if that's going to affect both. I wonder if we can set channel from the applier as well. maybe having them both be called the same thing wasn't necessarily the best framework there. But since we do have a set channel, we do have a set position, and we do have a get values, if we do a get position override, so we will come over here and I'll grab this. We'll come into enemy. So that set values is not found. How about like that then? Oh, that's why. It's not within the scope of that class. That should be fine now. Then we're going to have to do a get position. So enemy get position is going to return like this. Boom, 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 boom. Going to delete that for now. Going to save. We're going to go into loop here. Come on down. What I am attempting to do here is we're creating a system where managers handle all the things, and that our entities that we create are only in the initialization of the system, and then they're added to these managers, and then the managers are the only things in the update and render loop here. And I'm gonna kind of I'm doing a weird test here. And I don't know if this is going to work in the slightest. to be very honest here, and we're actually gonna add it right there. We're going to add our enemy. Our enemy is the mailer. And our enemy is the subscriber. That probably, let's see what goes on here. So from the top, yeah, that's ambiguous because there are an applier set channel, and there's the set channel for the status guy. So I definitely am going to want to change the name of that real quick, and that might be kind of a pain in the butt, but for the sake of this test, I think it's worth doing here. So I'm going to open up our manager. We're going to go into our interface, and here, since I have a status channel and a applier channel, I'm going to change this to set receiver and set sender. I'm going to save that. We're going to go into our signal manager. Just kind of looking here, because these functions here need to be implemented by those class. This here is how the signal manager works. I'm going to save this. I'm going to make clean and recompile that. So that should be recompiled. I'm going to go ahead, just close out of there. And then here, I'm going to have to change a couple names here. So let's start way back in basic. This set channel, this would be sender's channel. either senders or sender. You know, probably I'm going to keep this open just real quick. Yeah, sender channel. Go back to my other one here. So we have a set sender channel, and then for the UI, who's an applier, we're going to have a set receiver channel. And this is going to get rid of the ambiguity between the two functions when we have something inherit from both. This was not something I had foreseen, but I think overall it's going to be a more readable change here. And that way we'll set that to sender channel, and then for this one that needs to be a receiver channel. I'm going to just kind of move that off to the side for a second. That way I can go back and forth like that. Enemy needs a one of those and one of these. So we're going to override those functions. I'm going to go into player here. And this here is going to be a lot of kind of back and forth for a second, because when I go to compile next time, it's going to help us find a lot of these changes that need to be made. So you are a receiver, and then this guy is technically a sender. Yeah, so we'll go here. Just kind of checking here. Ba, 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 ba. And then in the enemy here, because we have both of these, then we can come up here and kind of define both. Like so. And it'll just be a... Ooh, that might be another ambiguity issue right there. So I'm gonna do a couple things because it has similar variable names, it is gonna appear to have that ambiguity, which is not the intention. And because of that, I'm going to have to change the name of some of these. So notice channel and channel. And now I do believe in Signal Manager. Yeah, this is where we're going to have to... and I'm sorry if this is a lot of kind of like cattywampus back and forth. For a minute, it's going to be kind of like that. Just because when I tried adding the enemy, I noticed that to kind of compensate for the collision system illusion break, that I needed the enemy to be both a receiver and a sender. And honestly, it needs to be that way anyway because it needs to take damage and receive the damage and be able to output damage through this signal guy here. So this is kind of an inevitable change. Clean here, clear, make. Looks like it compiled. I'm going to keep this open and put it off to the side. And over here, because of that ambiguity, we are going to need this keyword here or this keyword there. And I'm going to have to go through and change this for the other stuff that's already been defined here. So this is a receiver. That needs to be a receiver channel. This is a sender. This needs to be a sender channel. We're going to go into lighting here and just kind of see if it has a, yep, it does have a overwrote. This is going to be a receiver channel here. I'm going to go ahead, file, save that. And I'm going to compile. And this compilation here is to find the bugs. So here, so this error, I know what's going on here. So we can go ahead and fix that real quick. This is kind of like this issue, but with the enemy, it's expecting a vector instead of 2 floats. So we'll go here, and I'll do 400, 400 as before. We're going to compile again. And find the other errors here. So this is an enemy CPP, line 16. So make clean. We're going to go to this PPP here. This needs to be position.x. This needs to be position.y. So that's one of the many issues. Recompile. And here. Oh, there's no type there, so that's that's definitely it's definitely kind of funny. So that needs a type. Now those other errors here, the error virtual outside class declaration. So let's take a look here. Kind of do a make clean here. Doing some problem solving. So these are the last two, 21 and 26 of our enemy. And we'll kind of take a look here. So virtual outside class declaration, virtual void, enemy set channel int. Is it because, yeah. So here, this is kind of the funny thing. Even though you have a virtual inside the header, having that there is not something you want. Why it's that way? I don't know. Ask that one guy. So we do have a compile. We do have our squid there. Notice he's not animating. And if I bump into him, we still have this issue here. This is kind of the issue. You know, it might not be too bad of an issue with the enemies, to be honest. But because my goal was to make the illusion of bumping into them, that the world was not moving as well, we're still gonna stick with that goal there. So now, you know, we have a set position, we have set senders, set receivers, they're both at here. And inside the loop itself, we've added the enemy as the mailer and as the subscriber. And let's just take a look here at manager and just kind of parse through what may be happening with our enemy. So our receiver goes, hey, I want to set my position. So we're setting our position to whatever the sender's position was. And so what happens is when we bump into that object, the object is moving from that collision. And because it's moving, that position is changing, and it's changing its position relative to that. And I wonder here, because of how I have the channels set up, is if we subscribe the enemy to something else in the scene, and I don't know if that's going to work there. But for example, let's do, just for shits and giggles, let's set the receiver channel to 0. This is the same channel that the light is on. And we know that the light doesn't move. Well, maintains the illusion that it doesn't move. And I instantly notice that our light is gone. So let's try that again. Rightio. And if we put it on the player channel, what happens there? This is just kind of like a sanity check type of doohickey. And that makes sense, right? Because we're telling this this creature that, hey, your position is going to equal the player's position. And so that does make sense why it would be doing that. And I do wonder too, if we have it on a channel that doesn't have a sending, what it would do. Technically, it does the same thing that it would otherwise. You know, I think this is fine, honestly, because when we, that part, this is the part that doesn't make it so fine. Because some objects need to be completely static, and some objects do need to move. We're gonna put that back there. Honestly, this is the part that I've been avoiding, because I wrote this collision code, and it has a basically it will move type of thing. And we do, in a sense, need it to have the situation where when something collides with it, to kind of offset that collision. And the problem being, when it is collided, it's going to move both objects in that direction. And in some cases, you don't want that to happen. You only want it to happen when it's a movable object, in a sense. And so when it's not a movable object, you still want that collision to happen. You do not want any resolution to happen with the object that it was collided with. And the reason why I'm having a hard time, I guess, really understanding the proper way to go about this collision resolution detection stuff is if I only tell it, hey, the other sprite notice we still have that collision happen like so. And if I tell it, hey, don't have either, as you can suspect, you'll walk right through it. So we'll hit make here. We'll simulate. So now, we walk right through it. And if we do a cleanse and then only have the first one, save and make like this, we have the same instance happen as we did for the first one. And this is kind of the I wonder too, can we just, yeah. And this is kind of like the not really the issue with my collision code, but just the way it's set up is everything is checking for everything else, right? Like you have the player who bumps with the octopus or the player who bumps with the light pillar. And when that happens, the light pillar is also checking for that collision, so that resolution still happens. And that's because of this here, right? We are resolving the collision based off of that collidable. So on collision, takes in a knock, and we cast that knocker into a collidable, and then we resolve the collision from that, right? So we pass, this becomes collider, and then collision detection with resolution goes here. Collision detection with resolution says, hey, we have a result, so allocate a result, find the smallest axis. This is separating axis theorem for the collision. Create checks for the overlap, gets their positions, creates the finds the smallest axis based off of distance, tells it's true. Then we have a result, and then we return that result. And that result is here, and it is the actual movement. I wonder, because the smallest overlap here, just kind of look in here. What I'm kind of looking at here is really like this negative value You know, because I'm no collision expert, as you can tell. And the thing that we really want to do is only have the one guy move, or one guy be stopped from the collision. We don't want both guys to actually move there. And so there's a couple, like 2 ways I think about going about it. Like maybe make one opposite and don't have the other, and then wherever I'm looping through this data at, that only needs to check for really the one guy. So I'm going to go into our manager here and go into the collision manager. And right here, I think this area is kind of really like the issue. I'm going to save like that. I'm going to make clean, clear, and make. I'm going to then go ahead and go back to here. I think, because just kind of looking here, logically, if temporary A collides with temporary B, so if A collides with B, so player collides with object, we want to push player opposite. It's kind of what I'm thinking there. Let's go ahead and make. We will run the simulation. Ooh, that's kind of funky. I think I'm stuck. Because they're both still checking for collision at the end of the day. Shouldn't be, though. We'll test it like this one more time. Gonna test it like this. The purpose is we only want I think I got it. Haha. Okay. So that. Just kind of go over real quick why there's a problem, what the problem was, why it's not necessarily a problem, and why I wrote it the way I did the first time. So first off, typically when you check collisions, you want to loop through everybody, and you want to check A with B and B with A. This collision manager, what happens here is we are allowed to add a knocker to our list. So over here in interface, we have a iKnock, and what it's going to do is it updates the normals for all the entities, and then it's going to check, it has a function on collision. And that way, inside of our collision manager here, we can run on collision, who is a knockable, and then the update normals is going to happen for each knocker as well. So we have a update normals and a check collision guy. I'm going to file, save, close out of there, and then we're going to come over to our loop header. We have a manager lib, and this grabs all of our managers. And if we go over here to loop.cpp, you can see this is where we allocate. And then from manager lib, we can get the collision manager and we add things to our manager. And so this adds things to that list. And with that, then if we look here, collision itself has a couple things. There's a collision result. This is really a helper function. This collision function is also a helper function. This helps with the separating axis theorem algorithm, getting a minimum and a maximum. That way we can return both values by returning a type. You could use a vector, but this is one way to go ahead and return 2. And then in the actual colliding component, it is a knock, right? And because it's a knock, it needs that on collision. It needs that on update normals. And because we have those, the on collision here and the on update normals, these, even though they are defined here, and they're defined here because they implement that knocker function, we still can allow to have helper functions inside there. And usually, because you want A to B and B to A, you have both of these. Now, since initially I had it there and I didn't really want to mess around with it, that's kind of why I've been doing that workaround collision-wise. But this is overall better, right, for this case. And to kind of showcase that, I'm going to go back into loop here, and I'm going to remove the camera from the player here, and we're going to go here and create like this, and then run it. So notice what's happening here. And just to kind of show a little bit more here, notice how that UI was moving with the player. That's from the signal manager here. So now if we remove that signal manager as well, the UI will stay still. And if we walk into these pillars, the world is not moving. So this is more proper. Now there's no shenanigans going on with illusions like there were yesterday. And I'm overall kind of happy with that. To recap, what we've done so far for today is I went ahead and I made a here to pictures and go into squid. So I made a squid enemy using Aseprite. That squid enemy was then turned into code. That code was then placed into our, let me go into documents, GitHub, open template, asset preloader. That squid enemy was then placed into our asset preloader. That was updated to maintain loading that squid enemy and creating that data. We then went into our manager here, and from our manager in the interface here, I added that squid enemy. We compiled this this system here for both the manager and the asset preloader, recompiled both, And then from there, we added the squid enemy into our assets. I made a squid enemy header. That header has both a CPP and a header here. And the other part that I just kind of want to do real quick is we really do not need both a sender and a receiver. We even don't even need to redefine those. Set position here really doesn't need to be an override, and in fact I am going to take in two floats. And the reason why is I want to delineate the difference between the set position of an applier and a set position of a baser. So we'll do here, kind of like that. And then we'll take away receivers there as so. And then a value here we should take away. And then we're going to go back into loop here. We're going to just go like that and take him out of there. And then the set position is the only other thing we need to change. I'm going to file, save, compile. And this compilation is going to help us find any errors from the quick change here. Yep, so set sender channel into channel, no declaration. So void enemy, this is enemy CPP on 20. Why is it doing this? This is doing this because if we notice inside of basic here, because I override the function here and then I define the function here, in header I still probably have a override, which I do not. Let's go to enemy here. Probably because it was there and I wasn't overriding. It was either I had the override and then didn't define it, or didn't have the override and defined it. So we have our light source we can collide with no movement. We have our enemy we can collide with no movement. But now we want to be able to have a couple extra things here. Let's get some health onto the enemy, right? Because I did move the UI over to the basic area, and we do want a kind of like a health guy here for that enemy. I'm just gonna kind of look here, just kind of looking watchables for the camera. And what am I looking for exactly here is the UI, if it's a component. And it's not. It's not a component. How this works is, notice UI is its own separate thing. And this is going to have to change quite a bit here. I'm thinking we're going to want the UI to be over top of the entity, in a sense, and quite a bit smaller. So without adding it to the octopus right away, we're going to do this. And then this set receiver channel here as well. This is going to be kind of an issue. And we're gonna revisit this in a hot second. All right, and we're back. Now, let's, as I was saying, the set channel is going to be an issue here because we really need the UI not on construction to set the channel, but allow the channel to be set outside of here. So I'm actually going to go like this. Reason being is we want to maintain, for example, I'm going to call this player UI. We want to maintain this structure here. So player UI, and right here we'll do player UI dot set channel like that. And just kind of looking back there just for a second. Boom. It's called set receiver channel. So back here in loop, right there. This way, when we have multiple UIs in the scene, we can have each be to the thing that it needs to be. And the other thing, we want to shrink that UI down and kind of shift it over to the position closer to the entity that it belongs to. So here, we set the health, width, and height. This needs to be a smaller number, but still kind of maintain that. I'm kind of inclined to say, let's divide both by 4. And then the position here, this position really needs to be set based off of this here. Because these shapes, they do have a set position. But we really want this position to be more overrode and closer to the entity itself. So instead of, subtracting by so much, I'm going to kind of subtract by very little in the X. In fact, instead of subtracting, we might want to add, because the top left type of deal there. So I'm going to add in the X direction, and then that means for the Y direction, I'm going to go a little bit negative. I'm thinking, let's try -30 and -20 like that. And let's see where this UI ends up for the player real quick. Add to subscribed UI. That is because when we changed the name to player UI, I did not update that area. And there it is, add to subscribed. We'll grab player UI. And I'm going to double click on that and just kind of, that should be the only place in which that exists. We'll hit make. Player UI dot set receiver channel. It's a pointer, right? So that dot is a no-go. So we'll go there. Where's our set? Right there. That's a pointer. And compile here. Now we should be able to see. And so it's still a little large, and it honestly got over to the X a little bit more than I wanted, and so we'll continue some adjustments there. Go back into basic. I am going to have a subtraction. This height here, we're going to do more like a height of 5. And we're going to divide this number, let's divide it by 10. So make it really small. and we're going to subtract it. Since it's smaller now, we'll try subtracting by 20 and by 30 and 20 there. And what the point of this is, if we can set up a way where the player has his UI follow him, and then the enemy is going to have their own UI. But we want each kind of smaller. And that width is still huge. Because what's happening is this is 100 and this is 75. So let's say, that becomes a 10. We're zoomed in, so it's quite big. I'm going to do, about like a 20 there. And, we decreased the height as well. Oh, that's one reason right there. Let's see. So these values are set through the player, and because they're larger, it's not actually taking the change there. So like, if we, for example, change anything here, it really doesn't matter, other than the I think the height matters technically, but we'll see, because the height doesn't matter because we never put it there. So now we'll see some changes. Yeah, okay. So we do want those a little larger, and a little closer together there. Since this is kind of like the update portion, I'm going to stick right here, and I'm going to say divide those by 10. The set position here, this is fine, but we want those a little closer together now. And so I'm going to say 10 and 5, and maybe by like a 2 or a 0 there. It's going to be subtle. And if I hit H, yeah. So we're kind of a little closer, honestly. If we do like a -5 there, might be, and then just a little bit closer in the height. Let's try like a 5 and a 2. And this is just, small tweaks, small adjustments to get the UI to be, So this, I think this is fine. It shows, relatively the player's UI with the player. And we want his UI with him. And so I'm going to make clean here. And we're going to go over to the enemy. And our enemy, since it has its own health, its own stamina, we're going to create its own UI inside the loop and pair that with the enemy as so. So creating the allocation for the enemy UI, going into the loop CPP, we will go over to the this area here, and the channel for the enemy UI is going to be channel 2. So So we'll do enemy UI like this. I'm going to set the channel to 2. We're going to want it to be the enemy's health. We're going to want the enemy's stamina. And because this is a receiver channel of 2, we want the signal channel. So notice how we have this for the player. We're going to want this for the enemy. So we have an enemy and an enemy UI here. And I'm going to go back to the enemy CPP real quick. It is channel 2 for both. We'll hit make. The idea is that the UI for that enemy will be over the top of that enemy, and we do not see it. And as such, we shouldn't see it. This is part of the kind of the paradigm here, right? Because only things drawn to the screen are in the scene. Only things that can take input are part of the input manager. Even though they are added to the signal manager, notice that the player UI here was added to the scene. Enemy UI was never added to the scene. Without it being in the scene, it cannot be drawn in the scene. And so kind of having a manager paradigm like this allows you to see issues kind of before they happen, which is very nice. And now notice our enemy here does have health. Now we want that attack to interact with that enemy. And once we do that, that will be a good place to stop. So let's go ahead and check kind of like what we have going on already. When the enemy is on a channel 2, and then if we look at our loop here, if we notice on our input manager and fixed update, there's the send to mailers, the system. And it says here, hey, yo, event, if you push the H button, I'm going to look for our channel 1 guy, and I'm going to send a signal there. And so we're going to come over to our input manager real quick. So in manager, I'm going to open in terminal. I'm going to open up our code here and take a look at input managers, send to mailers. Right now we're telling it, hey, that value, we're going to have it equal 20. We really don't want this. We kind of want some type of damage here. Send to mailers really needs more than one parameter. If we look here, send to mailers is part of the input manager. So this input manager, once I add this value, it only needs to ever be added into this here. So we need, who are we sending it to? And then what are we sending, right? So I'm going to say for now, we're going to be sending a damage value. Now this name could change, but I think for this structure, this is going to be perfectly fine. And we're going to add a damage there. And we're going to take its values, and I'm going to minus equal damage as so. I'm going to file, save, and then I'm going to go into terminal here. I'm going to remake this file, and then I'm going to close out of there. And we're going to go back here. Now, technically, we now need some type of value there. And I'm going to file, save. We're going to compile this. I'm going to run it and hit the H key. And this will kind of give an idea. So when I hit H, notice every time I hit H, the health goes down. The idea here is when we swing, so if we are colliding and attacking, so if both happen, then we send a signal to that channel. So now we're going to go over to player here. And in fact, I think before I do that, in loop, because we know this system works, I'm just going to take that away. We have no reason to keep that in here. In player, we have a on check. Player is a controller. On check is really happening for that update loop in this manager here. And I'm just going to go ahead and look at input manager one more time. Send to mailers isn't happening in notify event at all. This send to mailers is its individual system here. And in a sense, we need a way for this information to happen down a level. Because the player himself, so if we go back to player, the player himself should have the information from C controller. So if we take a look at C controller here, he's a listener and implements these functions here. But those functions don't actually interact with that manager's function call right here, this send to mailers. As you notice, that send to mailers was inside the loop, because here is where we do have that manager lib. It is allocated, it is part of here. Player has no access to it. So we kind of want to have kind of like steps, right, going up. So we are going to edit a little bit of our interaction interface here. And a listener. So there's an on input, an on click, an on check, and an update. We may be able to keep these and then simply inside of our send to mailers have some type of listening thing happen here in the notify event, like, hey, on damaged, kind of seems like a decent way to go about it. And I want to say that might overall be the best way to go about this here. So I'm going to make a virtual void on damage, and we're going to take in a float here called damage. I'm going to go back into our input manager, and notice here send to mailers has a sender and a damage amount. Just kind of looking here. We're gonna make this a little bit different. I'm gonna have a set damage and a receive damage. This, I think, overall is going to help more so, because then we really just kind of check in here. What I'm moving this down here because I think I want a status and a receiver inside this on damage function. So I want a guy here. So we have a sender and a receiver. Just kind of checking here, looking around. So we have a on damage. That's in the listener guy. So in our input manager, And notice here, we don't have that information, but we do in the send to mailers. And so I think this is going to be kind of the area here. And we want an iApplier receiver here as well. And that way we can say sender on, I'm just kind of looking here because nope, that is a listener. Ba, 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 ba. Do it like this. So for our listeners, we're going to listen to sender and receiver on damage. Now, what is this function going to do with the that needs to be an iApply there. Receiver. What's this function going to do? This on damage. Well, this is going to be defined by he who implements iListen. So we're going to save this. I'm going to come in here and compile that, close it out, and now we have a lot of changes to do. We're going to go into basic first off because we're going to look at controller. Since controller is an iListener, we now need to implement a virtual void on damage. And on damage, it takes in a I status pointer called sender, and it takes in a I apply pointer called receiver. And we're going to override this function here. And this is in our controller. So we're going to go over here to basic, and I'm going to find controller here. Notice we have our on click, on check is empty, on input, update is empty. So very similar. We could say just on void on damage and keep this empty as well. And then only then override this in the player. I think I'm going to keep that paradigm since player does inherit. And then we can override here. So void on damage, override is so, and then on player, we're going to come over here. There's that check. I'm going to go above check and do, so let's call players class, do on damage here. And this is of type void, return type. And this is kind of interesting here. Yeah, this auto population is complete garbage. So basically, like, yeah, it's fine for now to have it on channel 2. Really, I mean, if all enemies are channel 2 type of thing, right? And we'll see how this this system scales over time. But we really want to kind of have these systems work together here. So I'm going to kind of go back here to the manager and just take a look at our input manager here. So on damage happens, and this is going to take in a sender and a receiver. The sender himself has a sent damage value, and we want to set this sent damage. And then from that sent damage, we're going to equal that to the received damage. And that received damage is going to set the value. So we're going to go back into our player here. And here, so set damage, and I'm going to say set damage is equal to, how about like a little larger number for now, like 50. This way the change is obvious. And if the sender is on channel, well, we really don't care about sender's channel. Really care about receiver's channel. So if the receiver if the receiver channel is the octopus, so if it's 2, then the receiver's damage is going to be equal to the sent damage, and the receiver is going to then set its values. Actually, not even set values, because that's going to be handled already. This right here simply should do the change itself, right? Because if we say receive damage, so receiver's receive damage is the sent damage, and if we look here for the input manager, on damage is going to happen, and the on damage, okay, yeah. So since we do define on damage, we do need to have that value change. Because set values is going to happen in our signal manager. So set values is checking, hey, I want my value to be whatever get value is. And so we need to change the value of our guy. And that way it will automatically update. So value, would it be, so receivers, is value? That is a good question. I'm going to go into interface here. So I'm kind of thinking here, because the octopus himself, he is the one who has the values, and he is a sender. We need a way to grab that sender's information this is kind of interesting, because we might need 2 I statuses here. The damager and the damagee. And because the reason why we need 2 senders here is it really doesn't matter what the received damage is. This set values here is occurring regardless. So if we go over here to player, and actually up to basics UI, so UI is a little bit down. Yeah, so set values is happening every time the signal manager updates, and it's grabbing those values from the same channel, if I'm thinking about that right. Right, because the player UI is on the first channel. Same with the player. Player and player UI are on the first channel. They are the mailer and the subscriber. So he sets this, and right now we basically want a signal transfer from one channel to the other. And ultimately, we do need to change his information because his information will then change that information, right? So here, this was a mistake of mine. I will call this the damager, and the damagee, damage E, and just kind of checking here. So those are two I statuses. Similarly here, so we need a damagee and the damager. I'm going to file save. And, we'll just make those and see what happens here. And just kind of borrow these real quick. And so this is going to compile this. I'm going to keep this up because I really need to maintain this. And so we're going to come back over to our player here, like so, and start back in basic because this is where the controller is. So there's a damager, there's a damagee, and we're going to come back over to controllers up here, and then there's that. And in player himself, we are going to override that. So we have a damager and a damagee. And here is our final damager, damagee. So if our damagers sender channel is 2. So, if the guy being damaged is on that channel, then we'll say, hey, his values in the X is going to be subtracted by the amount of damage that we do, and that should be all she wrote on there. And this on damage thing. This should happen only when we collide, and then when that button is pressed as well. And so if we look over, just kind of look here, so this is happening, bam, 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 and I think what's going to happen right away when I implement this is the octopus's health is going to shrink immediately. Because I don't have any use cases over top of this at all. There's no, if statements here. And I think how I'm going to end up doing it is these states here. So like something like if is attack state. Let's just do like is attack state right for now. Of course, this isn't checking for collision either at the moment. This should kind of help the visual testing for the moment. So let's see here. The only thing that I see needs to be checked is from the manager. So manager libs input manager. So we're going to get the input manager, and then we want the send to mailer. going to come back over here, input manager. This is what we want. And this send to mailers here, if we notice, it needed a single damager and a single statuser. Of course, you know, this is going to have to be different in time, but for now, I think if we did, let's do, get like the signal manager here. So if we do that and do, and I'm just going to kind of look at our signal manager, because what we want is our senders, because this is going to be our damager, and this is going to be senders at channel 1, so player's channel, and then our damagee is going to be channel 2 of our senders, like so. Of course, eventually we're not going to want any parameter here. This is going to want to just loop through all the things all the time. Maybe not all the time, but you know, we'll run it. So now if I click, we did have interaction, but notice it was quite intense interaction there. So let's go back to player here. Let's try to do it like that. That's probably not, you know, the all answer. Nah, it's definitely not. Yeah, especially since it breaks the animation there. Clean, clear. We only want this to happen one time, and for that to happen, just gonna kind of check through here. I'm gonna create a kind of like this. We're just gonna kind of go here. So that's attack down. This is attack right. We'll go like this. Hello, hello, guys. Right now, just kind of doing the sender-receiver logic here, having some cool cool bugs with the health. And if you want to make your own game engine, it's very fun. It is. It's one of the most both infuriating, kind of. It's hard. It causes a lot of brain power, but it's a lot of fun. Very much so. If damagee is on the sender's channel 2, sent damage, can damage is false. I might have to make a timer here. Just trying to make sure that health isn't disappearing or isn't going crazy like that. And you know, in fact, to try to help with that as well, we'll change the damage to like 5. And I think what's happening is it's the mouse press, mouse release type issue here. Because while key is pressed, you know, damage is being done. And it's only if I'm facing the right. Yeah, and we can really see that issue happen if we make damage like a really small number, like this. Because now it'll be very, very apparent of what's going on. So as long as you know, we're facing the right and this mouse button is clicked, notice the that health. Technically, you know, that's one way really to fix it in a sense, is keeping it like a really small value. And then of course in like the enemy script here, you could say something like, yo, if values is 0, then it is 0 type of thing, if it's less than or equal to. And so that that could be fine. I think for my case, having a small value here isn't the worst thing. And so I'm going to compile one more time and just kind of take a look here. The push and hold though, that is an issue with the push and hold, small value or not. And so because of that, down here, I created a timer system for the rolling state. And I think very similar, if we have a timer system for the attack state, it'll make sure that we don't have a similar issue here. Because we really only want the animation to pull, like you click, it plays it, and then you gotta click again and play it. Like a do once in Unreal Engine. And so if we look here, we got a timer. I think I'm going to keep the same cooldown. We'll see how this works. So we'll do a float attack duration. I think for now I'll set it to a 0.25 as well. And then here, go like this. I'm gonna go like that for a second. This initial state roll, I believe, is in collision, or not collision, is in controller. Right there. And so we want very similar, but for attack. So bool is, so initial state attack. And then we're going to kind of look here. Initial state attack is false always. Maybe not on this one, because this here, the click is the actual. And then notice this is kind of what's happening here. And so we're going to say initial is true. I do wonder too, I think we'll have both. So we'll do is initial true, and then we'll have the direction as well, kind of like so. And that way in the player here, so if the initial state attack is true and cooldown is ready, this we don't need. That was for increasing, decreasing the speed, changing it for the roll. And this is state roll guy. Just kind of checking here. Go back over to the controller. So when we hit spacebar, initial state roll becomes true. The actual roll is not true. So very similarly here. We want really the same paradigm. I'm commenting it out for now. We'll remove it once it works. So initial state roll is true when this is spacebar is pressed. Similarly, if I'm in this direction and I press, initial state attack is true. So here, with the roll system, when initial state roll happens, then is state roll is true. If initial state attack and cooldown is ready, the direction matters. And so I'm going to have to ask it the direction. So, if a direction, and it kind of auto-populated that, just check in, looks correct here, right, left is negative, positive Y is downward in SFML, so this is correct. This would be what, like attack duration here? And then if attack duration is less than or equal to 0, cooldown timer is set back, cooldown is ready, and initial state attack becomes false. Otherwise, initial state attack is false, or cooldown timer can then increase. Attack duration gets set back, is ready, and yeah. So this should be fine. What we're going to do is compile, and this is going to do two things. We're going to see what kind of errors we have. Similarly, I'm going to push, and notice nothing happens for my animations. And so let's kind of look logically here. In our update, this update's happening through controller. If initial state attack is true, cooldown is ready is true, and we're checking the direction. In this case, we are facing down. I click. So these two should be true. This should become true. So is state attack down? And if we look up here and we go, yep, so is state attack down? If this is true, this should play that animation here. So we're just going to kind of come down here. This should be true. And then we're going to subtract, set this back to false. And then the other one should be false as well. What we're going to do is we're going to do a debug.log in a sense. So I'm going to recompile. And we're going to ask it if this plays. So if we have this here, I'm not seeing any input there. So I did not verify that this is working. So what's happening here? Well, if we look, we have this scenario, but we don't really have our initial state attack at all up here. And I'm almost wondering, what all we need here. And so I'm gonna just kind of have cooldown timer and is a state attack down for a second. And we're gonna go back and forth, and we're really gonna be testing. So no animation, and just gonna kind of come back down here for a sanity check. We're gonna see if this is actually happening. So we're gonna say, hey, we attacked. Very likely, this is going to be more of an animation issue now than a state issue. Right, so when we push, we are entering that system. I'm going to comment that out there. And then up in, it would be right about here. And we're going to test if this happens here. And that does not happen. And I think I know what's going on here. If we go into basic, and we take a look at what's happening with this, we're looking for last direction. Direction is equal to 0 the entire time. So really we care about the last direction, not the current, because current is always 0. And because this is always 0, this is never 1. And because it's never 1, this is never true. Because that is never true, we had no way to reach here. So we'll go here, we'll compile, and we'll test. I'm going to click. And notice we do have that animation play once. This is exactly what I was looking for. So that is fantastic there. We can go ahead and remove that. I'm going to add this cooldown timer to the other states here. So is attack up and is attack right. And then we're going to do is attack left. And then we're going to come down here and make sure this is always the last direction we're looking for. To avoid issues like the one that I just had, always read your code, leave comments, try to remember the paradigms that you set up. The reason why right here I wasn't even checking for direction, and it was still it was working correctly for that roll. So it's just one thing to keep in mind there. And with that, now even if we set this value, I think to like a 10, and we compile, because that's only playing the one swipe per click. I'm going to come over here. E. That's still a bit much, right? So let's try like a 0.1 there. Yeah, still a bit large. 0.01. I noticed something too. It's that cooldown. I think having that just a small number in my case is going to be to my benefit. Yeah. Now we want to check for the collision and then that hit. And so this is where it's going to be kind of like a couple managers like combining, right? Because we have the collision manager checking for collision, and that is separate from the input manager who's checking for input. And this input manager here is looking for that damage, setting the channel, and I think like a very simple way to kind of go about this whole paradigm here is because we have a collision thing inside base, and we know that base here has that on collision guy. And if we go ahead and we look at what's happening in our collision manager, there's likely a variable that we can grab. And so that's actually not in our collision manager. That variable lives inside of collision itself. And that variable I'm looking for would be result. And just kind of checking here, collidable has a is colliding, okay. And where do we have a is colliding at? Right there. Do we have it anywhere else? Is that function even being used anywhere else? It is not. What I'm going to simply do here, this, may or may not be the best way to go about this. We'll do it like this. That way I can just call is colliding, or at least not call it, but check it. And this here, I believe, is a component. So we'll have to call this collision guy. So collision and this is the other part too. And I'll kind of show this this off real quick. Because this isn't the end all be all either. Oh, it's private. That's okay. We'll do here. So right now it's checking for any type of collision. And so even though like I can go like this and his damage won't happen unless we are colliding, I believe. Maybe not. Interesting. Huh. I really would have thought that would have transferred over through there. Guess we'll have it like this. And we'll also print that out. Go here, boom, boom. Make a sim. Ba, 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 ba. Unless it's a very small value. Because it is in fact colliding. I don't see an is attacked at all in there. Let's make clean, clear, and we'll go back over to so we'll comment that out and check for the other guy real quick. There it is. Now the glitch I was going to show is even if we're here, notice, right? And that's because we're just checking for, am I colliding with anything? And that's where things are going to have to kind of have a little bit more conciseness to them, right? Because if we can damage, if collision is colliding, and then the thing that we're interacting with, we're really going to want to check if that is you know, the thing we're actually colliding with there. Just check in. Because here's my idea here. If we have both is colliding and result is collided, if both of these are true, that's kind of like the ideal case. Now the enemy himself, the enemy is a base. The base, looking here, is a status. Right, and we have a status. So can I dynamically change status to base and then check for the base's collision? And I think I can. I think a dynamic cast would be fine there. So notice we have a damage E. And so, for example, we could say, hey, we'll do like a base pointer temp, and we're gonna cast damage G into base, and then we're gonna say, hey, if we can damage, if this player is colliding and our temp collision is colliding, then the player attacked, and we do the damage on that channel. And just to check, I'm over here at the light. I'm going to swipe at the light. No health is going down on the octopus. We're going to walk, and boom. And right now, left would not do that, down would not do that, and up would not do that. And so that's the last thing we'll do here. I'll make clean, I'll clear, I'll go like this. Ken damage needs to happen on, I believe that was in basic controller. You know what? That isn't a Ken damage there. So player. So we have a Ken damage. And that was on the right hand side, if I remember right. Yeah. So this is kind of like where I was placing that stuff. And so we're just going to add this into the other animation area. So if a state is attacked down, Ken damage can happen. And then this is attack up. We can damage. This is the right hand side. This is the left hand side. Attack here. Ken damage. Now we want a Ken damage is false on the rest of these, just for consistency here, to avoid any errors or bugs. So Ken damage here is false, false, and again. Then a couple more times here. This one, that one, there. That has our, and that looks good. And so now we have successfully implemented this system where when the player is colliding with the enemy and the attack happens, that attack actually occurs. There's a light source in the scene that changes the lighting, and all of this is happening through the manager system inside Loop. And so over here, the render system is in charge of rendering the scene. In update, the signal manager is checking for the update. The collision manager is checking for the collisions. The input manager is checking for information. This is the one part that, and I'm going to leave a comment here, and we're going to say send to mailers. So send to mailers needs to loop through all senders and receivers to check for damage messages. And that's because player himself, I think that's actually upward here. That's because player himself is specifying the channel. But yeah, I think so. This has been to kind of summarize one more time of what all has happened in this stream here. I made a squid enemy PNG that has been turned into code here. That code was then placed in our asset manager library and has been allocated. We build this library here, and then updated the necessary components in the library manager itself. I'm going to go ahead and just make sure all that is saved. I'm going to close out of those. I'm also going to close out of here. And then inside of this Souls-like, and just I'll kind of show here real quick for the viewer. If we make clean on our asset, and then we come over here to Souls-like, and we try to compile this, this will fail. We'll get an error because it's looking for our asset library. That asset library lives in its own folder. It can be compiled separately, and that way it is independent. And now if we make this, it finds that information, and it in fact works. And just to make clean like that and clear, just to kind of show through here a little bit. Manager, the manager folder, this is more like the game engine itself. So game engine, this is independent of the application. What assets do I want for this game? And this is the logic for that game. And so if we come in here, I'm going to make clean for a second, clear, and enter the code. The interface itself class, it dictates, hey, this is our window size, here is our assets, here's the layers that we're gonna change and use. Then we have our different interfaces here. Our sender and receiver signal manager uses the status. Our collision manager uses the knocker. The scene manager uses the drawable and the watchable. And this is our input manager. So our input manager loops through our listeners, checking for damage or key presses. And in this case, like a key is pressed, and then it's also checking for the damage to be dealt. Our signal manager here is saying, hey, we're looking for a signal between position, and this is to set that UI per entity, and then the value is really its health area. Our scene manager here has a camera follow and rendering all the things that belong to a layer all at once. And then collision manager is checking for our collision here. And that way, and I'll go ahead and compile this. That way, when we go into the actual game logic itself, we have in our main file just a simple, hey, go ahead and play this this game here. The header goes, hey, we're going to want a initialization and a fixed update and update and a render. And then this is going to have a couple things here, right? Like the player has a UI. The enemy, of course, is going to be in a list eventually. Then the light pillar also would be in a list. Ideally, we would have one container here that holds all the things, and then from there initialize them type of stuff. Maybe next time we'll go ahead and organize a little bit more. And play calls are protected functions here. Initialize, then while the window's open, run this loop. Initialization is grabbing our library from our manager. Notice manager is not a header. Well, it is a header here, but manager lib is not. And that is where it's coming from, that actual library file. And then, we go through, we add these things to our scene, we add them to our signal managers or collision manager, and we really should clean this up as well here. for example, here I'm going to make like a void add to scene, a void add to input manager, a void add to signal manager, and a void add to collision manager. And that way, we can do this loop, and then we'll do add to signal manager, void loop, add to scene, void loop, add to input manager, void loop, add to collision manager. Just kind of like this. And the only thing I see might be an issue here is the idea of the container there. And so just for kind of shits and giggles here, before we call it a day, I'm going to make a game objects header. Kind of like this. And this this here would contain our guys. So if we go into loop here, these are our different guys. I'm going to control X there. We will place these guys here. Notice it has no idea where that information is coming from. We can go ahead, grab these right out of loop. No longer needs them there. We'll pragma once up here. And then I think what we'll do here is we'll have some getter functions. So like a get player. We'll have like a get player UI. Kind of like this. Except these need return types. So this is going to return a pointer to the player. This is going to return pointer to the UI. This is going to return an enemy pointer. This is going to return also a pointer to the UI. And this will return a light pillar pointer. As so. You know what? That's probably better for organization. So we have this, and then we'll do a file, a new file, gameobjects.cpp. And here I will include our game objects. And from game object, that is not correct, but that's fine. Those are fine. This is what we need to change here. And in fact, I think we'll even have an init function here. Kind of as so. And then we'll take in an asset here. So kind of like that. And yeah, so that should be fine, technically. And then we're going to go into loop here. Include game objects. And then inside the loop itself, so here, we included the manager lib. We'll do game objects is game object, and then we will initialize our game objects. And then all of this crap here is where we're going to organize into these. So I'm going to grab, see if those are all our signal managers there. So those are our signal managers. We're going to grab collision manager next. So there's 1, 2, and 3. So we'll grab those. We'll add those there. And then we will grab our input manager. I believe there's only one for the player. Like so. And then our scenes. We'll grab all of those and we'll put those here. And then instead of having any of this allocated here, I just want to double check. Yeah, that seems to be about the same. We don't want any of this here. And the way I'm going to go about it is we're going to call add input manager. So add to input manager. Then we're going to add to the collision manager. Then we're going to add to the signal manager. And then we're going to add to the scene. So this just kind of organizes things a little bit. And the last thing we need to change here is these areas here. Specifically this stuff. So for example, this would be game objects dot get light, and we want its collision. Game objects get enemy. Get player. And then here, this would be game objects get player. Similarly for the layer, so we want the player himself to be added to the camera. We want the player's current view added to the player layer. We want get player UI. So this would be game objects that get player UI. And then this would be similar game objects that get enemy UI. And then this light here with the current view thing, very similar to here. We want those. And then enemy would simply be this. And then we gotta change some things here. So we will get the player, grab the enemy, and then we need player UI and enemy UI. So we'll do enemy UI. This would be player UI, and then we have to grab those lights. so. And yeah, so everything should work as before. This is just a different way to organize. So we'll compile here, and we'll check some of these errors. So, so we'll look at game objects in it. Should be of type void. So that was one issue. And then what's this other issue here? Let's go ahead and check through this real quick. Just make sure that they are receiving the proper thing. So this takes in an asset reference. Loop itself makes an asset pointer. And so this is a pointer that needs to be dereferenced. And if we go into loop here, the this is dereferenced. And because that's dereferenced, then inside of game objects, that's reaching there. That was dereferenced coming in. So I believe should be fine like so. And if not, we'll pass this pointer and then dereference on the inside. Does getPlayer not have a type? That's funny. I didn't even notice that. So, of course, you know, these need their corresponding types here. And what kind of thing are you called? So that's definitely part of the shenanigans there. Seems to have compiled. And yeah, there we are. And we have damage. And I think for today, this has been a pretty good improvement upon what we have here. And just to kind of showcase, if we go into GitHub here, this is how much has been changed. So for however long this this stream was, there has been a lot of changes here, and overall, I think we have made a lot of good progress. And with that, if you want to learn C++, I suppose one of the best ways to go about it is the Cherno on YouTube. He is a really good C++ channel, and I can show that here. If we go to YouTube here and take a look at this guy here, he has a lot of C++ courses. He used to work for EA. So I would highly recommend checking his stuff out. And then another way to learn C++, and this might sound kind of wild, is learn Java or C Sharp. Because if you know Java and C Sharp, you already know kind of, sort of, some C++, but it'll definitely make a whole lot more sense. So with that, see you guys.